Welcome back at the FinetLeak channel. Today we will continue with IPv6 addressing part 2. At the first part, we explained the need for the IPv6 addressing. We also explain how the IPv6 address are represented, and we compare types of IPv6 network addresses. And in this part of the IPv6 addressing, we will explain how to configure static, global, unicast, and linked local IPv6 network addresses. And we will explain how to configure global unicast address dynamically and how to configure linked local address dynamically. And at the last part, we will be focused at how to identify the IPv6 addresses and to implement a subnet IPv6 addressing scheme. As we learned at the first part of IPv6 addressing, the IPv6 global unicast address are the same as the public IPv4 address. They are globally unique and routable on the IPv6 internet. And for the local link address, it's similar to the private IPv4 addresses and lets two IPv6 enabled devices to communicate with each other on the same subnet. It is easy to statically configure the IPv6 global unicast addresses and link local addresses on routers to help us to create an IPv6 network. The differences comparing to the IPv4 counterpart configuration is that instead of using the IP commands, we use the IPv6 command. And here it is an example, and it is a topology as it is shown here with 3 subnets. And those subnets are connected together and want to communicate together. So here it is shown how to configure the IPv6 global unicast address on a Giga Ethernet 0/0/0, Giga Ethernet 0/0/1, and the serial interface 0/1/0. And as you can see, every time that we will go at the interface, we will use the IPv6 address. Then we will write down the address that is for that interface, and at the end we will use the prefix length. And this is for each of the interfaces that we mentioned before. Manually configuring the IPv6 address on a host is similar to configure an IPv4 address. As it is shown here, the default gateway address is configured for the PC1 as it is shown here at this line. And this is the global unicast address of the router 1 Giga Ethernet interface on the same network. Alternatively, the default gateway address can be configured to match the link local address of the Giga Ethernet interface. Using the link local address of the router as a default gateway address is considered the best practice. Either the configuration will not work. And just as the IPv4, configuring static address on a client does not scale to larger environment. For this reason, most network administrators in an IPv6 network will enable dynamic assignment of IPv6 addresses. And there are 2 ways in which a device can obtain an IPv6 global unicast address automatically. And these are the stateless address auto configuration and a stateful DHCP version 6. The stateless address auto configuration and DHCP version 6 are covered in the next slide, and we will explain how they work. And configuring the link local address manually lets you create an address that is recognizable and easier to remember. It is only necessary to create a recognizable link local address on router. And this is a beneficial because router link local address are used as default gateway addresses and in routing advertisement messages. We will show you how to configure manually the IPv6 address, and we will use this example topology with linked local addresses, as you can see, for each interface of the router that is connected with each subnet. And the example of the configuration on a linked local address on the router one is shown here. And you have to remember that every time that we want to configure a particular interface, we will write down the IPv6 address, and then we will write the IPv6 link local address followed by the link local command. And here are for each interface of the router. Most devices obtain their IPv6 global unicast addresses dynamically, and there are the process that works using the router advertisement and router solicitation messages. For the global unicast address, a device obtains the address dynamically through the Internet Control Message Protocol version 6 messages. The IPv6 routers periodically send these messages every 200 seconds to all IPv6 enabled devices on the network, and the router advertisement message will be sent in response to a host sending an Internet Control Message Protocol version 6 router solicitation message, which is a request for a router advertisement message. And both these messages are shown here in this figure. The router solicitation message are sent to all IPv6 routers by host requesting addressing information, and the router advertisement messages are sent to all IPv6 nodes. And depending on the method for the router advertisement will include the network prefix, prefix length, and the default gateway information. The router advertisement messages are on IPv6 router interface, and the router first must be enabled for IPv6 routing, and we will explain in the other topics how you have to configure that. For the moment, it is important to know that the IPv6 router advertisement message is a suggestion to a device on how to obtain an IPv6 global unicast address. The ultimate decision is up to the device operating system. The Internet Control Message Protocol version 6 router advertisement message will include the network prefix and the prefix length, which will tell the device which network it belongs to. Will have the default gateway address, and this is an IPv6 link local address, the source IPv6 address of the router advertisement message, and the DNS address and domain name where there are the addresses of the DNS servers and a domain name. And there are three methods for the router advertisement message. The first one is the stateless address auto configuration, and it's like that I have everything you need, including the prefix, prefix length, and the default gateway address from the router. And the method two, it is the stateless address auto configuration with a stateless DHCP server. And in this case, it's like the router says that here is my information, but you need to get other information such as DNS address from a stateless DHCP server. And at the method 3, with the stateful DHCP version 6 server, all the information can be got by the DHCP version 6 server. And it looks like the servers say, I can give you the default gateway address, but you need to ask a stateful DHCP version server to all your other information. So not all the information can be found on the router. The only thing that the router can give you in this moment is the default gateway address. At the method stateless address auto configuration, allow device to create its own global unicast address without the service of the DHCP version 6 server. The router advertisement messages suggest that the receiving device use the information in the router advertisement message to create its own IPv6 global unicast address and all other necessary information. The service of a DHCP version 6 server are not required. The stateless address auto configuration is stateless, which means that there is no central server allocating the global unicast address and keeping a list of devices on their address. With the stateless address auto configuration, the client device uses the information in the routing advertisement message to create its own global unicast address, and as it is shown here in the figure, there are two parts of address that are created as follows. So we have the prefix and the interface ID. The router sends a router advertisement message with the prefix to the local link, and the computer uses the stateless address auto configuration to obtain a prefix from the router advertisement message and creates its own interface ID, where the interface ID uses a process by generating a random 64-bit number depending on the device operating system. But a router interface can be configured to send a router advertisement using stateless address auto configuration and a stateless DHCP version 6 server. As it is shown here in this figure, with this method, the router advertisement message suggests device using the following. Using the stateless address auto configuration to create its own IPv6 global unicast address, the router link local address, which is the router advertisement source IPv6 address as the default gateway address, and a stateless DHCP version 6 server to obtain other information such as DNS server address and a domain name. So, how this works in this case, this method. So, the PC sends a router solicitation to all IPv6 routers that are connected to that network, in this case to this subnet. And it will say that I need addressing information because he needs to get an IPv6 address. At the other way, the router will send a router advertisement message to all IPv6 nodes with a second method, with stateless address auto configuration and DHCP version 6 server, which is stateless, and it says that here is your prefix length, and default gateway information. But you will need to get DNS information from a DHCP version 6 server. And the third step is that the PC will send the DHCP version 6 holistic message to all the DHCP servers that are connected to that subnet, and will say that I use the stateless address auto configuration to create my IPv6 address and get my default gateway address, but I need other information from a stateless DHCP version 6 server. And then the last step that is not shown here, the server will reply to him with the DNS information. And the third method, a router information can be configured to send routing advertisement using the stateful DHCP version 6 only. The stateful DHCP version 6 is similar to DHCP for the IPv4 networks. A device can automatically receive its addressing information, including a global unicast address, prefix length, and the address of DNS server for a stateful DHCP version 6 server. As it is shown here in this figure, with this method, the router advertisement message suggests devices use the following: the router link local address, which is the router advertisement source IPv6 address for the default gateway address, and a stateful DHCP version 6 server to obtain a global unicast address, DNS server address, domain name, and other necessary information. And let's see how these three messages, as it is shown here in the figure, work. At the first one, the PC will send a router solicitation to all IPv6 routers. I need addressing information, he will say. And the router will send a router advertisement message to all IPv6 nodes with a third method, and he will say, I am your default gateway, but you need to ask a stateful DHCP version 6 server for your IPv6 address and other addressing information. And after that, the PC will send a DHCP version 6 soliciting message to all DHCP version 6 servers, and he will say that I have received my default gateway address from the router advertisement message, which means from the router, but I need an IPv6 address and all other addressing information from a stateful DHCP version 6 server. A stateful DHCP version 6 server allocates and maintains a list of which device received which IPv6 address. And DHCP for IPv4 is stateful also. The default gateway address can only be obtained dynamically from the router advertisement message. The stateless or stateful DHCP version 6 server does not provide the default gateway address as it is in the IPv4 networks. And when the router advertisement message is either using the first method, stateless auto configuration or stateless auto configuration with stateless DHCP version 6 server, the client must generate its own interface ID. The client knows the prefix portion of the address from the router advertisement message, but must create its own interface ID. The interface ID can be created using the EUY64 process or randomly generate a 64-bit number as it is shown here in the figure. And you will see that the router sent a router advertisement message, and the PC will use the prefix in the router advertisement message and use either the process EUY64 or random 64 number to generate an interface ID. The extended unique identifier or modified extended unique identifier 64 process use the 48-bit Ethernet MAC address of a client and insert another 16-bit in the middle of 48-bit MAC address to create a 64-bit interface ID. We know that the Ethernet MAC address are usually represented in hexadecimal and are made from two main parts, from the organizationally unique identifier, which is a 24 bits vendor code, and a device identifier, which is a unique 24 bits value. And by using this process, the interface ID is represented in binary, and it is made from three main parts. There are 24 bits from the organization unique identifier, the client MAC address, but the 7th bit, which is the universally local bit, will be reversed. So if the 7th bit will be 1, it will become 0 and vice versa. Then we will insert 16-bit value in hexadecimal as FFFE, and the last part is the 24-bit device identifier from the client MAC address. Here is the process illustrated, how to go from the MAC address to the interface ID in hexadecimal notation. The first one, we will identify the two main parts, and we will split the MAC address. And after you will split the MAC address, you will insert the 16-bit value as FFFE in binary format. After you do that, you will go to the 7th bit at the universal local bit, and you will flip this, which means that you will convert if it's 0 to 1 and if it's 1 to 0. In this case it is 0, so you will convert it at 1. And after you do this, from the binary format you will convert it as a hexadecimal, and you will get the interface ID, the IPv6 address. So, and if you, every time that you use the ipconfig command to show the IPv6 global interface, you will understand that it's been dynamically created using the stateless address auto configuration and the extender identifier 64 process by checking the IPv6 address. And here you can see that by checking this IPv6 address, you will have the FFFE as it is extended at the MAC address. And you will see that this is IPv6 address obtained by the stateless address auto configuration and the extended unified identifier 64 process. Depending upon the operating system, a device may use a randomly generated interface ID instead of using the MAC address and the extended unique identifier 64 process. After the interface ID is established, either through the extended unique identifier 64 process or through random generation, it can be combined with an IPv6 prefix in the router advertisement message to create a global unique address as it is shown here in this figure. All IPv6 devices must have even an IPv6 local address. You can also create these addresses dynamically. Regardless how you create your link local address or your global unicast address, it is important that you verify all IPv6 address configuration. In the figure, it is shown the link local address is dynamically created using the FE800:10 prefix, and the interface ID it is created by using the extended identifier 64 process or randomly generated number. But the operating system will typically use the same method for both a stateless address auto configuration created global unicast address and dynamically assigned link local address. If you use the ipconfig command, you may be able to identify how this IPv6 address was created. And here in this case, you will understand that it is randomly 64-bit generated interface ID. And the Cisco router automatically creates an IPv6 link local address whenever a global unicast address is assigned to the interface. By default, the Cisco iOS routers use extended unique identifier 64 to generate the interface ID for all link local address on IPv6 interface. Here at the example, it is display the MAC address of a gigabit Ethernet interface of router 1. This address is used to dynamically create the link local address on the same interface and also for the serial interface too. And as you can see here, you may be able to understand how the IPv6 are created for each of those interfaces. And as we mentioned, at the Cisco router, all are recreated by using the extended unique identifier 64-bit to generate the interface ID. And in case you want to verify, there are many commands that you can use for verifying the IPv6 address configuration. For doing that, we will use this topology, and we want to see the IPv6 addresses configured at each interface of this router 1. By using the show IPv6 interface brief, we will be able to display the IPv6 address of the Ethernet interfaces, as it is shown here. By using the show IPv6 route, we will be able to verify the IPv6 networks and the specific IPv6 interface addresses that has been installed in the IPv6 routing table. This command will only display IPv6 network and not IPv4 network. Another way is by using the ping command for the IPv6, which is identical with the IPv4, but expect that this one will address only IPv6 addresses. As it is shown here, this is a command that is used to verify the layer 3 connectivity between router 1 and the PC 1. That was all the information regardless for the IPv6 addressing part 2. Thank you for being with me and see you to the next session.